Thanks, William, and welcome everybody to today's Tech to Tech. Want to thank you guys for joining us and taking your time out of today to watch this quick informational. We're going to take about 10 minutes and introduce what I think is one of the best quality control techniques that you can use for testing the cleanliness of your part after cleaning. It's called Dyne testing, and whether you're dealing with a cleaning or a coating or adhesion process, this is a method that helps us make sure that your surface is actually ready for its next steps. So we'll break it down into some simple terms so that everyone walks away with a pretty clear understanding of what Dyne testing is. So the big question, what is Dyne testing? Well, Dyne testing is a way to measure the surface energy or the surface tension of a material using a liquid that has a known surface tension to it. And so why does knowing the surface energy of your part, why does that matter? Well, if we want to do something like paint or glue two pieces together, or you want a coating to stick properly, then the surface needs to have the right amount of surface energy for that to happen. So a Dyne's test is a quick way for us to confirm whether that the surface is prepared enough for you to have a successful bond. So Dyne testing is commonly used to check whether oils or other contaminants have been removed from your part after cleaning. It's really useful if you want to see whether the coating has been compromised or that the coating has an adhesion requirement for the surface of your part. So think of Dyne's testing as sort of your initial pass-fail score for whether for your finished product. You know, whether if you know that the surface tension of the adhesion requirement, then that's a really quick, easy test. You grab the correlating Dyne value, you swab your part, and you can determine whether or not, by a quick test, whether you would have successful bonding to your part or not. So, you know, this is not just about preparation, but it can also be about ongoing quality control throughout your production or the cleaning process at your facility. So here are some practical tips sort of to make sure that you're getting an accurate result when you're using Dyne fluids. First and foremost, you want to always test at room temperature. So extreme colds or extreme heat will skew your testing or your test. Definitely make sure your parts are cooled if they're coming out of a wash process. Secondly, you know, choose your starting Dyne level based on how the part looks or feels. And then third, soaking the swab and applying too much pressure is going to flood the surface with the ink and not give a desired result, really. So you want to make sure that you're just putting just enough fluid on it and using light pressure to make the swab or the swipe across to get your desired results. And then, you know, not all surfaces are going to give a uniform reading. So if they have grooves or if there's a different texture to one part of your part and not another, it's going to read differently on each of those surfaces. So let's take a look at a real world example. You know, in this video, you see Chelsea, our lab manager, swab a metal plate, and half has been cleaned. One half that has been cleaned, you see that whatever that value of Dyne fluid that she was using on that swab is immediately beating up. This means that surface tension of the metal is the same as the surface tension of the value of the Dyne fluid that she is using. So the right side of the part is what they call wetting out, and this means it has a higher surface tension than the value of the fluid that she is using. So she would have to move up to the next level, Dyne fluid, to get a more accurate reading. Just another example of the Dyne pens that you can also use. We do not necessarily recommend them, although they do have their purposes. And here on these parts you're seeing on the left-hand side, the Dyne fluid has met, because it's beaded up, it has met its the surface tension of whatever value it is. And then on the right-hand side, Those are wetted out, which means they have a higher surface tension than the fluid that was used. So, while Dyne's testing is useful, it's not completely perfect. Parts with deep grooves or heavy textures, the fluid's not going to spread out properly, and you're going to get unreliable readings. The same goes for the surfaces that are still heavily contaminated. It's going to skew your results as to what you're seeing. Of note, Dyne solutions above 72, which they don't sell a lot of, but they start to dissolve water-soluble residues, and then they'll give you a false sense of cleanliness, which 72 is considered perfectly clean. So you shouldn't have to go above that anyway. But when it's used consistently, this is a quick pass-fail test that you can run on your parts for a process control, and it gives you a pass-fail of whether you're ready to move on to the next step or not. Just a quick side note, even though I said 72 is perfectly clean, we typically tell customers that 60 dynes or higher is considered completely clean. So in conclusion, Dyne's testing, it's a fast, effective method to evaluate your surface energy, to see whether you're ready to go on and your surface is clean enough to go to the next step for coating or adhesion or whatever that might be. Accurate results do depend on the technique, swab pressure, the perfect amount of Dyne's fluid on your cotton swab, etc. Temperature. Always take caution when you're reading your results, and question but verify what you're looking at. And just know that this is a reliable process monitoring tool that you can use with a pass-fail threshold to make sure that your parts are ready to go on to the next step in the process. So, a few frequently asked questions that we have on the topic is, what's a typical Dyne level range used in testing? And so Dyne testing usually covers surface energy ranges from 30 to 72 dynes per centimeter. So it's said that for most industrial applications, for proper adhesion, anything above 38 dynes is considered acceptable, but in some high precision cleaning applications, at least 50 plus dynes is required for them to pass or fail. How do you know which dyne level to start with? Well, typically what we tell people is just, pick a dyne level somewhere in the middle range of where 40 to 50 dynes per centimeter, if you're unsure. If the ink spreads out evenly and stays put, try a higher level. And then if it beads up too quick, go lower, because you want to swab and wait about 2 seconds for the beading to start. That's when you're at the proper value of surface energy. Can you reuse Dyne pens or swabs for multiple parts? Well, we don't recommend using Dyne pens most of the time. What we look at is if you swab a dirty part with that Dyne pen, then technically you've contaminated the tip of it, and you're going to have, you could have skewed results. What we recommend is buying the vials of the Dyne fluid and using a clean cotton swab with each pass. That way you're never contaminating the ink. And then why is surface energy important for cleaning and coating? Well, it determines on how well, any kind of liquid or paint, adhesive, or a coating is going to stick to your surface. So if your surface energy is too low, you're going to get poor coverage or maybe peeling or weak bonds. So Dyne's testing is a quick, fast, and effective way to ensure that your part is actually ready to move on to the next step. So if you guys want some more information on this, a little bit higher level, our Dr. Adam series covered Dyne's testing a few months back, and he goes a little bit higher level than what we're going here. And if you want more information, you can get a hold of any of your KYZEN representatives, and we'll be happy to help you with that. And with that, I'll give it back to William.